Hi, this is Ron Cipcic, and this is the first part of a two-part series on price elasticity of demand. This term elasticity is a term that we'll be using quite a bit through both parts of this study, and you can think of elasticity simply as the term sensitivity. So let's write that down. So wherever you see the term sensitive, you can think of elastic. Wherever you see the term insensitive, you can think of inelastic. Those terms are equivalent. Now, somewhere prior to this lesson, you have encountered the law of demand, and you already know that when the price of something increases, buyers generally buy less of it. And when the price of something decreases, buyers generally buy more of it. We have not looked, though, at the question of how much less and how much more. In other words, how sensitive is the buyer to the price change? Now, business people care about this a lot. Let me explain why. If you take the price of a product and multiply it by the quantity demanded, you get the total revenue. Now let me just come up here I'll come up here just on the side. If you take the total revenue and subtract the total cost, you get the bottom line, which is total profit. Yep, profit is the bottom line. It's below the other two lines. So anything that increases total revenue, assuming you're holding total cost constant, has the potential of increasing total profit. Likewise, anything that decreases total revenue, holding cost constant, could potentially decrease total profit. So business people are very interested, obviously, in profit, and profit is a function of revenue, and revenue is a function of price. So what happens if the price of something goes up, but buyers buy significantly less of that product? So the price goes up a little bit, but the quantity goes down a lot. Well, you're going to see that revenues are going to fall. Whereas over here, suppose the price of something goes up significantly, but buyers don't end up buying that much less. Well, revenues could actually increase. So if the buyer is very, very sensitive to a price increase, revenues could fall. If the buyer is very, very insensitive to a price increase, revenues could actually rise. So the response of revenue to a price change is going to be dependent upon how sensitive or insensitive buyers are to that price change. Very, very important principle to business people. Not just principle, very, very important dynamic. It's an actual real-world dynamic, the sensitivity of buyers to a price change. The government also cares a lot about this issue. You go, why? Well, governments have to raise tax revenues to finance their spending. All right? One way that governments raise tax revenues is to tax specific products. And if you think of the big three products that are taxed in the United States and really throughout the world, they're going to be products like what? Tobacco. Tobacco products are heavily taxed in America. What else? Alcohol. Alcohol products are heavily taxed in America. And what else? Petroleum products, gasoline, heavily taxed in America. You say, why? Well, what do all three of those products have in common? The buyers of those products are relatively what? Relatively price insensitive. So if the price of the product is raised through a tax increase, that's what a tax increase does. It will increase the price of the product. That will lead buyers to buy less. But if the product is a product where buyers are relatively price insensitive, they won't buy that much less, and actually revenues, company revenues in total will increase, and the government will be able to take a greater piece of those company revenues. So government is very, very interested in the inelasticity or elasticity of buyers, and much tax policy, not all tax policy, but excise tax policy in particular, is driven by this issue. Well, let's go ahead and use a couple examples to illustrate these concepts. So first we're going to start with the price sensitive case. We're going to assume that buyers are price sensitive to price changes. So suppose you have a hypothetical product price 200. And suppose that businesses are selling 100 units of that each day, each week, each month, excuse me, each year. Total revenues $20,000. And we'll bring those same numbers over here. 200 times 100. Whoop. Let me use my fancy smancy eraser function here. Get rid of that little extra wiggle. Back to our pen tool. And this equals what? This equals 20,000. Okay. Now, let's start with the price sensitive case. We'll change the color here. Say that the price increases to $250 per unit. Say that sales drop to $60. Now, this is a very, very dramatic drop in sales. The price increase, if you calculate it, is what? This is a 25% increase in the price. The sales dropped from 100 to 60. Well, what is that? That's a decrease, and it's a 40% decrease in sales. Why? Because minus 40 over where you started, 100 minus 40%. So we see here that the price, relatively speaking, went up a little bit. Sales, relatively speaking, went down a lot. What's going to happen to revenues? Well, if you actually do the calculation, revenues are going to decrease. So here, business people raised their price 25%, but their sales dropped. Why? Their buyers were what? Their buyers were relatively price sensitive. So you have a relatively price sensitive buyer here. Why? Because the percentage change in Q, in terms of the absolute value, forget the negative sign, the percentage change in Q was significantly greater than the percentage change in P. Okay, let's go ahead and do the other side of this. Suppose that business people raise their price from 200 to 250 again. Well, again, this is what? This is a what? This is a 25% increase in price. But suppose that sales only drop to 90. Well, this is a very, 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 very small decrease in sales. In fact, if you calculate it, it's a minus 10 over 100. It's 10%. So sales only dropped 10%. Well, buyers here are relatively what? Insensitive to the price increase. They're not responding a lot to it. Guess what happens? Total revenues actually increase to $22,500. The point is, if I raise my price and my buyers don't respond much to that price increase, my revenues are actually going to increase. Of course, this would be the type of product that government would like to what? Use an excise tax on. You would expect that this would be the type of product that government would be looking for to place an excise tax on. This is excise taxable because the buyers are relatively what? Price insensitive. Price insensitive. Now, of course, there could be a third case here. We're not going to draw it, where the percentage change in P and the percentage change in Q could be equal, and then in that case there would be no change in revenues. Okay? Now, what I want to do is I want to formalize these principles. So I'm going to actually move this canvas up, and we're going to write out the principles, formalize them, and help you see the logic here in clearer focus. So how do you measure the price sensitivity of buyers? How do economists get at this idea? Well, I'll tell you what, red is a little bit too much. So let's get rid of the red here, and let's go to black. Okay, how do economists measure price elasticity of demand? Well, there's actually several ways. This is one method, and it's a method that's generally used in explaining this at the principles level. There are some other methods, but the basic idea is to calculate something called an elasticity coefficient. So this is an elasticity of demand. Actually, it's price elasticity of demand coefficient. A coefficient is nothing more than a $5 term for a number. So we're looking for a number that will give us some indication of whether buyers are sensitive to price, insensitive to price, or neither. The basic idea is to take the percentage change in the quantity demanded and compare it to, divide it by, the percentage change in price, and take the absolute value of that number. So we're going to take the percentage change in Q, absolute value, which means we're going to ignore negativity, and we're going to take the percentage change in P, again, absolute value, we're going to ignore negativity, and we're going to look at the ratio between those two. Now, just a word about absolute value, just a little side lesson on the math here. If you take the absolute value of A, you get A. A is a positive number. The absolute value of a positive number is that number. If you take the absolute value of a negative A, you get A. So we apply the absolute value restriction to the formula to get rid of negative signs. We're interested in magnitude, the size of the number, not the sign of the number. Notice this number will always be negative, and that's why we have to apply the absolute value signs to it. Think about it. If P goes up, Q goes down. So if P is positive, if the change in P is positive, the change in Q will be negative. So a negative over a positive is a negative. If P goes down, well, what happens? Q goes up. So the change in Q would be positive, the change in P would be negative, and again, positive over negative is a negative. So you always get a negative number when you compare the percentage change in QD to the percentage change in price. So we put the absolute brackets on here to get rid of that negative outcome. We're interested in the size of the outcome, not the sign. We already know the sign. We know the sign will be negative. By the way, this formula could also be expressed this way: percentage change in the quantity demanded, absolute value, over the percentage change in P, absolute value. So to say the absolute value of A over B is to say the absolute value of A over the absolute value of B. So those are interchangeable, and you'll see how that's important in just a minute. Okay, let's just think a minute. Let's go back to our example. I want to just remind you of something. In the price-sensitive case, remember in the price-sensitive case above that Q dropped by 40% when P went up by what? 25%. Now think about this. We're going to actually formalize this in a minute, write this out. But let's just think about it before we write it out. Negative 40% absolute value is 40%. Okay, so this is really 40% absolute value terms. This is 25%. 40% divided by 25% is got to result in a number greater than 1. Yep, it has to. It has to. In fact, if you divided 40% by 25%, you would actually get 1.6, which is a number greater than 1. So if the numerator is greater than the denominator in absolute value terms, that's the key idea. If the numerator is greater than the denominator in absolute value terms, this ED has to be greater than 1. Okay? Now let's go to the other case. We looked at the price insensitive case. Remember, the price went up by 25%, but buyers only bought 10% less. They were not sensitive to price. Very sensitive. Well, again, get rid of the negative sign because this is an absolute value calculation. 10% to 25% is actually a number that is what? A number that is less than 1. Actually, if you calculate that, that's going to be 0.4. Is that 0.4? Yeah, that's going to be 0.4. Let me just think about this one over here again. If you divide 40% by 25%, I don't have my calculator handy. What is that? That is... Yeah, That's 1.6. Okay, we're good. So it's a mathematical fact. If the numerator is what? If the numerator is greater than the denominator, this has to be greater than 1. If the numerator is less than the denominator, this has to be what? This has to be less than 1. That's going to be a key idea moving forward. Of course, there's a third possibility. If the numerator equals the denominator, if a number is divided by itself, then ED equals 1. Okay, now let's move that up and let's write out our rules. Okay, so I'm going to move this up. It's a very interesting scrolling feature, isn't it? You wouldn't believe how long it took me to learn how to use this. I had serious problems with this. I am suffering for you. I want you to know that. That was a commercial break from your suffering instructor. Okay? All right, back to our regular programming. All right, so let's write out the rules. Let's write out the rules. If I don't want that color, I want black, but I don't want that red color, so let's get rid of it using our erasing tool. Isn't that cool how that works? Very good. All right, we got rid of that. Back to our tool here. If the percentage change in the quantity demanded, say 40%, is greater than the percentage change in price, say 25%, then what's true? ED has to be what? Greater than 1. And it is. Has to be greater than 1. And it is. Okay, has to be. What does ED greater than 1 means? Well, if Q is changing in percentage terms more than P is changing, buyers are what? Buyers are, what are they? They're price sensitive. Or we could say demand is what? Demand is elastic. Elastic. Okay, let's do it again. If the percentage change in the quantity demanded, say 10%, is less than the percentage change in price, say 25%, then what's true? ED is less than 1. So if the numerator, 10%, is less than the denominator, 25%, then the ED, what? The ED has to be less than 1, 0.4. Right? 0.4, 0.4, 0.4. So what's true here? Buyers are what? Buyers are price insensitive. Which means what? Demand is inelastic. Okay? Demand is inelastic. Buyers aren't responding a lot. Again, come on. Hey, hey. If this is what? If this is 40, if this is 40%, if this is 25%, this has to be greater than 1. Greater than 1. If this is 10% and this is 25%, this has to be what? This has to be less than 1. Okay? All right, and of course there's a third possibility. We haven't talked about it. Let me go up and let's move this up just a little bit. The third possibility, of course, would be where they're equal. And that's an important thing to say because it at least gives us the fence line or the border. So if the percentage change in the quantity demanded were equal to the percentage change in price, right? Then what would be true? ED would have to be what? Equal to 1. And then you have the neither nor case. Neither sensitive nor insensitive, neither elastic nor inelastic. So yeah, if I could use a different color here, if this is 25 and this is 25, then the ED equals what? The ED equals 1. Now that's almost never going to occur. That's rare, but that at least tells us what the fence line is. All right, so what we've done here in lesson 1 is we've connected the percentage change in Q to the percentage change in P to get what? To get a measure of price sensitivity. Now in our next lesson we're going to actually use this to look at how price changes ultimately affect revenue, and we'll be illustrating this with something called a demand curve. Okay? We'll see you then. Take care.